Good morning, friends. Today we will talk about data structures. So, what is a data structure? A data structure is a particular way of organizing data in a computer so that it can be used effectively. So, it's an arrangement of data. So, by arranging the data, we can make our program more effective. Okay, so why we need data structures? So digital computers primarily uses primitive data, zeros and ones, which need not require any extra effort from the user side. But in real world, we require data other than primitive data type, which require extra effort, like storage representation, retrieval of stored data, transformation of stored data. For these requirements, we use data structures. So if we are representing everything as zeros and ones, no need of data structures. But we have been handling with wide variety of data like audio, video, text, all that things. In order to handle all these things, so many things will come. How to store the data, how to retrieve the data, how to transform the data. So we need a proper arrangement. That's why we are studying data structures. So use of data structures is used in for programming design. So in the design phase, data structures comes. So first we will gather the requirements. After gathering first of all we will identify the problem. Based on that we will design. We will acquire the requirements. Based on the problem we will design. During the design phase we will decide what data structure we have to use. Data structure is a major component for writing efficient programming and manage real and abstract data. So it's a very important fact content. Data structure help in mastering the application in real software product. So it's very much useful. Okay, before studying about data structure, we have to study about some terminologies. All these terminologies we already know. I'm just refreshing your ideas and knowledge. Okay, first one, data types. You know, every variable will have a type assigned with it. Okay, there are two type of data types are there. Built-in data type is there. Abstract data type. Abstract means user-defined data types. We already studied C programming where we have the built-in data types like int, character, float, like that. Abstract data type, for example, structure we have. Okay, so abstract is a union. All these are abstract data types. So now you are studying Java and Python. Okay, in that you define classes. So class is also an abstract. Okay, another important component is domain. Domain means range of value data can have. Suppose I'm taking age as a data structure, then the domain will be only numbers. We cannot enter any character. That's a domain. Then functions, set of operations which may legally be applied to the data objects. So there are certain operations that we can perform to the data structure. Suppose take the case of a name. We can perform different operations like addition, subtraction, like that we can perform in normal numbers, but we cannot perform that in a string. So there is some limitation in the amount of functions, whichever functions we can use for that particular data structure, data. Then axiom means set of rules which different functions belongs. So means what are the rules that we have to follow while writing the function, while performing the functions. That's axioms. So these are the three components. One is data type and three components: domain, function, axioms. Okay. Now it's time to properly define data structure. Data structure is triplet. Contain three components: DFA, where D is a set of data objects. Data structure will contain the data objects. F is the set of functions. So it also defines the function it has and is a set of rules to implement the functions. A is the axioms. So data structure contains three things. We will define the data domain of the data, then function of the data, and we will define the axioms of the data. These three things will be defined in a data structure. Okay. By simply means it's not a simple arrangement. By arranging the data, we also define three things: the domain of the data, the function of the data, and the axioms, means set of rules to implement that functions. Okay, you see examples. So integer data types, it's a primitive data type. Okay, you already know that. A domain is this addition, plus or minus 1, plus or minus 2 integers. It will support all integers. That's the domain. So 0, plus or minus 1, plus or minus 2, etc. And functions, it can perform addition, subtraction, multiplication, etc. Okay. Rules. A is the axiom, rule to perform addition, to perform subtraction, like that. So while defining the data structure, we have to specify that these three components: domain, function, and the axioms. See more examples. This is another data structure, complex data type. It's an abstract data type. We can create a complex number addition using structure in C program. The same concept we can implement using class in Java or Python. Okay, so where we use it's a user-defined data structure, not already defined. It's not a primitive data type. It's an abstract data types. So we are going to define the domain. Domain means it should have a real part and imaginary part should be there. Then functions, it can perform addition, subtraction, like that. Operations it can perform. Axioms, so what's the rule for addition? Take the case of a rule of addition. So we have to add a real part and imaginary part separately. So that's a rule. That's the axiom. Data structure specify how every object of di, I equal to 1 to n, is represented. It also checks how functions are implemented using the axioms. That's a very important statement. So it will give all these things. What's the domain in it? How the functions are being implemented in it. Okay. Now we will classify the data structures. Data structures can be classified into two: linear data structure, non-linear data structure. In the case of linear data structure, we have arrays, linked list, stack, queue. Okay. And for non-linear data structure, we have trees, graphs, tables, sets. We will cover all these things, except I think tables and sets we are not covering. Remaining things we are being covering. Among this arrays you already know. You have implemented several programs and you learned arrays very much. Okay. This tutorial question that that's you have to implement. So you have to define an abstract data type date. Okay, having three components: dd, mm, yy, where dd varies from 1 to 31, mm varies from 1 to 12, and yy is an integer with 4 digits. Specify f. You have to define the functions consisting of all possible operations, and also defines a to implement the operation of f. You can perform addition. Addition of 2 date is possible. Subtraction of 2 date is possible. So such things. What is the rule for that? Another question: devise a data structure graphics. So you want to define a data structure graphics to represent the graph data as shown in the figure. Also define the following operations on any of the data of this type. Okay. Scale up. We want to scale the data. Scale down. Then rotate. All these operations we can perform that. Okay. Now we will talk about the first data structure, array. Already we know arrays. Okay. So what is an array? If we want to store a group of elements, then we will use arrays. Okay. Elements are stored in contiguous memory location. Array elements are of same type. Homogeneous. It's purely homogeneous. Array is a linear data structure. So you already know about arrays. Okay. Now we will discuss about the applications of array. Already, as we know about arrays, we will come to the applications of array. Before discussing applications, let's talk about this one. Okay. Abstract data type. Okay, abstract data type is a mathematical model of a data structure. ADT or abstract data type is a model of the data structure. It describes a container which holds finite number of objects. Okay, so ADT will define the domain. It is concerned with what data is represented, not concerned with how it will be constructed. So abstract data type, we are not thinking about how the data is being implemented. We are not thinking about the implementation. We are just showing how it will be represented. It contains objects, operations, and rules. The same thing, domain, functions, and the rules. So only thing is that it's a mathematical model of a data structure. So while studying about different data structures, we will come to this ADT. What it gives is it provides an abstraction. Abstraction means we don't need the inner detail, how the things will be implemented. It will show you what are the things it should have. Okay, so if you want to implement, you have to use this. That's the advantage of this ADT. The ADT is just a mathematical model of the data structure. It defines three components, the same domain, function, and the axioms. Same thing, what we have said. Only thing is, it's just a mathematical model, and it represents the data, not concerned about the implementation. It's not concerning about the implementation. Okay, take the case of array. Array as a data structure. Array as a data structure. When we are considering array as a data structure, we have to define the three components: data, the operations, and the axioms. As we already know this, we are not deeply going through this. We are just seeing the data. Okay, data part. Data part we have to. It should be a homogeneous. The area array space means the space of the array where we will have the homogeneous data. We should have a homogeneous data. Then we have to find variables are there, length. Using the variable, we can find the length of the array. Then array size will be there. Then typical operations we can perform in an array are display, append, insert, delete, search. So see the example of the function insert. So what ADT provide is how we can use this insert function. So while implementing insert function, you have to pass two arguments. One should be the index of the array, and second should be the array element to be inserted. These two things we have to specify while implementing array. If we are writing an insert function without passing this, it's not the array data structure that we are implementing. It's an arrangement that we made, not the actual array implementation. So what ADT provide is it just creates a model. So if it's same as a class. Class means suppose I want to create a student class, a student details. I want to give information about student. I will create a model of the student. So similarly, data structure array as a data structure provides a model that it should have all these things, and we have to follow these rules. Another function delete is there. If you want to call the delete function, we have to pass the index. Like that, if you want to search something, we have to pass the key value. These rules we are specifying in the ADT. It's just a systematic arrangement where it is just a model where we can get all these informations. So what we do is that if you want to use a data structure, array we have already know, but when we come to other data structures, what we do is we will check the ADT. Okay, it's just a model. So where we will see what are the domain, domain it can have, or what functions it can perform, how the function will be have to be implemented. All that things will be clear there. That's advantage. So we will use that ADT model to implement. That's it. Okay, axiom, set of rules for these functions. There are rules for implementing these functions. So advantage of ADT is that ensure robustness and reusability. That's very it's we can reuse the components because already everyone will, if I implement an array data structure, not an array data structure, what it means is that if somebody is using my code, they can easily know that okay, I will be, if I'm calling insert function, if I want to if I implemented a program using array data structures and somebody want to call that insert function, then they will know that if I'm using the array data structure, I have to pass the two arguments in order to call that function. Okay, so that information will be clear. I don't want to know how it is been implemented. Other user don't want to know about how it is been implemented because I have already implemented that. Only thing is he want to use that. So it reduces coding effort. So coding effort will be reduced. Encapsulation ensure data cannot be corrupted. So in how insertion is being performed, that is been hidden from the user. Other user don't want to know about how it is being implemented. So we are not thinking about that. We are just thinking about how to use that. So ADT will provide an information. Okay, this is the structure. It will be more clear when we discuss about other data structures. What we do in real life is that if you want to use a data structure, suppose map is a data structure. I don't know how to use the map function. What are the functions it is being? If somebody implemented that, I want to use that his or her program. What I will do is I will check the map data structure. Okay, from that I will be clear. Okay, I have to perform these operations to to call these functions. Suppose I have an insert function there for for calling that insert function. I have to pass something. Okay, so maybe an array. I have to pass. Then I will create an array and I will pass that to that map insert function. So that information will be provided by ADT. Okay. Now we will discuss about the applications of arrays. Actually, as we already know about array, we are not discussing deeply into arrays. So now we will discuss about two applications of array. One is polynomial representation. So if I have a polynomial, I can represent in using array. So there are certain conditions out there. There may be arise some situations where you need to evaluate many polynomial expressions and perform basic arithmetic operations like addition, subtraction with those numbers. For this, you will have to get a way to represent those polynomials. Okay. For that, we will use the arrays. A simple way to represent a polynomial with degree n and store the coefficient n plus 1 terms of the polynomial is in the array. Okay. So how to represent that? A polynomial of single variable a of x can be represented as a0 plus a1x plus a2x square plus etc. up to an x raised to n, provided an is not equal to 0 and the degree of a of x is in n. Okay, we can represent like this. Simply representation. Only thing is what we do is we will represent the coefficient here. So this value is coefficient. X raised to 0's coefficient will be represented in the 0th location. X raised to 1's coefficient will be represented in the 1th location. X raised to 2's coefficient will be represented in the 2nd location. Like that, it will be represented. So let's say take an example: 5x square plus 3x minus 10. Okay, it's a polynomial. I want to represent that. First thing what we do is we will fill up the missing entries. So 5x square plus 3x minus 10x raised to 0. So x raised to 0 term will be minus 10. That will be represented in a of 0. X raised to 1 term coefficient is 3. Is 3 represented in a of 1. X square value will be represented as in 2th location, like that. Another example: 10x cube plus 13x plus 11 can be represented. Here x square term is missing, so we will add a 0 there. So 10x cube plus 0x square plus 13x raised to 1 plus 11x raised to 0. Same thing, x raised to 0's coefficient is 11. So the x raised to 1's coefficient is 13. X raised to 2's coefficient is 0. X cube's coefficient is 10. Okay, this is one of the applications of arrays. So another very important application of array is sparse matrix. So what is a sparse matrix? Two-dimensional array having values of majority of elements as null or zero is a sparse matrix. Means most of the entries in that matrix will be zeros. So if we are representing, so I'll show you an example. Okay, this is a matrix where most of the entries are zeros. So if we are representing like this, it's a wastage of memory because only we are storing zeros. Only few values are there. 1, 2, 3, 4, 5, 6 values are there, but this much memory is been using. So we use some other method to represent this. Okay, so storing null value is a concern. What we will do is we will use an array representation. Represent the sparse matrix is a triplet. How what the triplet representation is? First of all, I will show you the example. First thing is I will create a matrix like this, and in that matrix, first entry will be number of rows of the sparse matrix. 1, 2, 3, 4, 5. 5 rows are there, so it will be represented as 5. Number of columns I will check 1, 2, 3, 4, 5, 6. That will be 6. And third will be the number of non-zero values. So number of non-zero values here is 1, 2, 3, 4, 5, 6. 6 values. Next thing is where are these values? So I have first value is in 9. Its location is 0, 4. 0, 4 is in the 9 block. Another value 8 is there. It is in the 1, 1 location. Next one 4 is there. 4 should be represented in the location 2, 0. Okay. Then this 2 is there, 2, 3. Then 5 is there, that is 3, 5. Then this 2 is there, it's 4, 2. So we will represent like this. Lot of memory we can save. So idea is like this. First we will represent the number of rows, number of columns, number of non-zero elements. Then elements will be represented. It's a row index and column index, and the non-zero element will be present. Only the non-zero elements will be represented in this representation. Somebody asks you what's a sparse matrix? It simply means a matrix having more values, zeros. So that can be represented like this using a triplet representation. There is another application of arrays. Next module we will talk about